Right, today in this webcast I'm going to show you how to use a calculator to figure resistance with multiple resistors in a parallel circuit here. Alright, so I'll start with Kirchhoff's current law, which states that the total current in any circuit is equal to the sum of the current at each of the nodes in the parallel circuit. Okay, so basically the total current is going to be equal to the current at node 1, 2, and 3. And what I'm using, if you want to follow along here, I'm on page 184 of your text, and I'm looking at example 6-7. Alright, and then we'll go ahead and substitute for the current in each of those nodes. We'll just substitute Ohm's law. Okay, so the current at node 1 is going to be the total voltage divided by the resistance for resistor 1, and same thing with node 2 and 3. Alright, and then I'll move down a page here a little bit, and I'll again do a substitution here and substitute total current is going to be equal to the sum of the voltages and the total resistance. And if I take and factor out the total voltage, I get some inverses here, so that the inverse of the total resistance is going to be the inverse of the resistance at node 1 plus the inverse resistance at node 2, and then the inverse resistance at node 3. And then my last little mathematical feat here, we want to find out the total resistance, so we take the inverse of all that. Okay, so what this looks like from an equation standpoint, to figure out the total resistance in example 6-7 of page 184, we take the inverse of, well, the inverse of 100 ohm plus the inverse of 47 ohm plus the inverse of 22 ohm. Okay, well, let's look at this from a calculator standpoint. Alright, so I'll pull out my calculator here. I'll clear the screen, and really this is quite simple to do. Here's your inverse button right here on your keyboard, and so I'll put in 100, and then I'll find the inverse of that, and then I will add to that 47, and I'll find inverse. Whoops, let me go back here. We'll start over again. I'll take 100, find the inverse, add to that 47, add the inverse, add to that 22, find the inverse, complete that. Okay, so I come up with 0.0767, and now I find the inverse of that. I'll hit enter, and that comes out to approximately 13 ohms. Okay,